Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem number LeetCode 50 pow x comma n. The problem statement says that implement pow x comma n which calculates x raised to the power n. So we all know this function pow x comma n, and we just have to implement here this function. This function does nothing but calculates x raised to the power n. So in the example one we can see the input is x2 and n is 10. So the output is x raised to the power n, that is 1024. And let's see how we can implement it. So before that I would like to just check some constraints. So the constraints are n is from minus 2 to the power 31 to 2 to the power 31 minus 1. This we all know, 2 to the power 31 minus 1 is around 10 to the power 9. So this n is going till 10 to the power 9, and this is going negative also. So in the function the input x is double and integer n is an integer. So we can see that n is negative also, so we have to handle the case of negative also, but we will handle this, that's easy. And but we have to take care that this n is going can go till 10 to the power 9, and it is also written that either x is not 0 or n is greater than 0. It means that we don't have to deal with the case 0 to the power 0. We don't have to manage that case. All right, so rest is okay. Now let's see how we can implement it. So the problem statement says that we have to implement the function x to the power n. So the brute force approach which can come into my mind is we can take an answer 1 and we can run a for loop from 1 to n, and every time we just keep multiplying x with our answer. So this way we will keep multiplying x n times, so we will calculate x to the power n. But we all know n is can go till 10 to the power 9. So this big O of n time complexity we can't afford because it will give TLE. So we have to optimize it. So let's see what we can do. So there is a standard classic formula or concept, you can say, of binary exponentiation or fast exponentiation. What it tells that if we have to calculate x to the power n, we can just check that if x is odd, if n is odd or n is even. So we can write it as, if n is even, we can write it as x square to the power n by 2, and it can also be written as this x to the power n can also be written as x into x to the power x, wait, if n is odd, if n is odd, this x to the power n can also be written as x into x square to the power n by 2. All right, so this is also known as, this formula is also known as binary exponentiation or fast exponentiation. This helps us in calculating x to the power n in log n time. All right, so let's see what it does. That suppose we are given 2 to the power 10, it tells that if n is odd, if n is even, here we can see 10 is even. So this can also be written as, according to this formula, this can also be written as 2 square to the power 10 by 2. Okay, so this 10 by 2 we can write this as 5, and this 2 square can be written as 4. Now we will call recursion, and we will just also ask recursion to calculate this 4 to the power 5. So we can see now this n is odd, 5 is odd, so we can just, according to the formula, we can write 4 outside, and inside this will be again 4 square into 5, 4 square to the power 5 by 2. Now this 5 by 2 is 2 and this 4 square is 16. So that 5 by 2 was 2, this 4 square was 16. Now again we will call recursion and we will ask to calculate this power. So this can be written as 4 is outside, 4 was already outside. Now this is even, this can be written as inside 16 square to the power 2 by 2. Now 2 by 2 is 1 and 16 square is 256. So 2 by 2 was 1 and 16 square is 256. Now again we will call recursion. So this n is odd now. So we can say that the 4 was outside and this n is odd. So we can call this inside number outside, and we are just using this formula only when n is odd. So this can be written as 256 square to the power 1 by 2. Now this 1 by 2 we all know this is 0. So anything power 0 is 1. Now this is our edge case, not edge case, this is our base case, that whenever we will see any n equal to 0, we already know that anything power 0 is 1. So this we will handle as base case. So anything power 0 can be written as 1. So I am erasing this and I will write here as 1. So now this will be our answer. So this will be 1024, and we already know that 2 to the power 10 is equals to 1024. Somewhere it will be written also 2 to the power 10 is 1024. Alright, so we can see that we have calculated the 1024 in some small steps, 1, 2, 3 and just 4 steps. But this is very time saving than big O of n. And if we calculate exactly how the number of steps, we can calculate using the normal formula which we were told in college exams to calculate time complexity. So if we calculate, we can see we are just dividing n by 2 every time. Each and every time we are just calling n by 2. So that's why we already know that if we divide something by 2, so it becomes, the time complexity becomes log n base 2. So that's why this formula, also known as binary exponentiation, this helps in calculating x to the power n and does this in big O of log n base 2 time complexity, and this is the optimal one. Alright, so now we will implement also. So what I think that we can implement this using two ways. First is the recursive way and the second is the iterative way. So what I think, if we implement this using recursion, it will take extra stack space, the recursive stack space, the internal stack space. But if we will try to implement it using iterative case, this will not take any recursive stack space. So alright, this is on our choice that how we will implement it. So I am explaining also that how does the iterative method works. So let's take example of this 2 to the power 10 only. What we will do, what we will just take answer variable 1. You can just think of we are just implementing this recursive function in an iterative method. So we will just take answer as 1, answer variable as 1, and this 2 to the power 10 will be now converted to, we all know this has power even, so this will be reduced by the half. So this will become 2 into 2 by 5. This will become 5. 2 into 2 raised to the power 5. Now here we can see this, if we see this 2 to the power 10 as a form of x to the power n, then this x is multiplied by x again. All right, and this n is reduced by 2. So can we say if n is even in iterative case, if n is even, so can we say x is now x into x and n is now n divided by 2? Here we can see similarly, after saving this will become, x will become 4 and n will become 5. Now we have to calculate 4 to the power 5. Now we all know this 5 is odd, so in the odd case what we were doing, we were just taking this 1 4 out, and we were just writing 4 square here and 5 by 2 here. So this can also be written as so this can also be written as 4 to the power 4 square to the, this can also be written as 4 to the power 4. So we can see here in the odd case, in this odd case when n is odd, if n is odd, we can say that we have just taken out 1x from here, and this will be multiplied with our answer. This 4 we have taken out will be multiplied with our answer, so we can say this will be multiplied with our answer, and this n is reduced by 1, we can see here. So this, in this odd case, our answer will be multiplied with x and n will be reduced with 1. Now again we have to deal with 4 to the power 4. Our x is 4 now and n is also 4 now. So now we have to calculate this. So this 4 is even. So in even case our x was multiplied again. So this will become 4 into 4 and this n will decrease, divide by 2. So again this will become 16, 4 into 4, this will become 16. Now we have to again deal with this even case. Now this 16 will become 16 into 16 and this will be divided by 2 and will be divided by 2, this will become 1. Now 16 into 16, let me check what 16 into 16, this is 256. All right, so we should write here also 256. And now this is odd case. So in odd case what we were doing, we can observe from that binary exponentiation formula also, and here also in the iterative case we are just doing the same but something smartly, so that we can do it in iterative method also. So we are just reducing this power by 1, so this, and we are taking just x out, so x will be taken out and this inside power will be reduced to 1, this will be power 0, and this outer thing will be multiplied with our answer will be multiplied with 256. All right, now we all know that something power 0 is already 1, so this will be 1, and now we will just return our answer. So our answer was 1 into 4 into 256, this is 1024. So this is our answer. So we can see we have seen two approaches here. First is using the binary exponentiation method, and second is the iterative approach using again the binary exponentiation method, but just doing some things extra, not something extra, but just analyzing it, how can we iterate this using while loop, not using recursion. So we can use any of the methods, but I would prefer this iterative method only, because this will save our memory of that recursive stack, that's why. So I'm going to implement this recursive method only. So first of all, what we have to do, we have to just this we have to just return our answer. So let's declare our answer as 1.0. And yes, we know that n can be negative also. So in the negative case, when n will be negative, what we will do, we will just suppose we have to calculate x to the power minus n. So can we say this x to the power minus n is nothing but 1 upon x to the power n? So we can go and calculate x to the power n, and at the end we will just return 1 upon answer. All right. So I'm using another variable m, because see, our input is n and we are just manipulating or modifying n. So modifying input is not a good practice during interviews. That's why I'm making another variable m. So for the safe side, I'm using long m, and this will be n. And I will check if n is negative, then I will multiply m with -1, because if n is negative, we will just calculate x to the power n, and we will at last return 1 by x to the power n. All right. Now what I said, while n is greater than 0, sorry, m is greater than 0, what we will do, we will just check that if our this case, if n is even. In our case, we have taken m. So if m is even, what we say, if m was even, we have to just multiply x by x. All right. And now we have to just reduce n by 2. All right. And also in the else case, if m was odd, what we were just doing, we were just multiplying our answer with x, and we were just reducing our n by 1. Now after coming out, we will check if n was negative, we will say that our answer is nothing but 1.0 divided by the answer, and at the last we will return our answer. But before running, first let's check if we are handling the edge cases also. Double answer, long if n is less than 0. All right. If even case, and here we are using m, so I should divide m, not n, and m will be -1. All right, so we are ready to run this. Yes, we are able to pass the sample test cases, and let's submit it. So yes, we have solved this problem successfully, and we have understood two methods. First is the recursive method, and second is the iterative method. The recursive method is more, I would say, transparent. It's more easy to implement, and it's more very transparent and very intuitive also. And I like this method, but this will take this same time complexity, but extra, I would say, space complexity of big O of log n of that recursive stack. But in this iterative case, we can see that time complexity is just big O of log n. That's every time in recursive also, but here the space complexity is big O of 1, because we are not using any space. So this was the recursive method. This is more easy to implement, but this will take extra space. Of recursive stack only, that's, I think it's all right. we can implement that also. And this is iterative method, which can be derived from that binary exponentiation method. And this its space complexity is big O of 1 and time complexity of both method are big O of log n. So we have understood both the methods to implement x raised to the power n. And that's all for this problem. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.